All right, let's start. Yeah, great to see so many people joining today for this presentation about DevOps on embedded systems. We've got a lot of people joining from inside and also from inside Nalys, but also other companies. So it's great to see, yeah, a lot of people today. The idea of the NTech webinars we host is to promote interaction and discussion between inside Nalys, but also between Nalys and other companies. So yeah, it's NTech is an entity next from Nalys that tries to develop the sharing of this knowledge. Okay, so today, what are we going to have a look at? We'll talk about DevOps for embedded system development. So first bit, in a general sense, what is DevOps and some context around it. Then the classic way of developing embedded systems, the software development lifecycle for that. And then more specifically, how can we apply some of these DevOps principles to embedded system development? And then we have two use cases from projects that we did at customers. One covering an embedded Linux embedded system development, and one for microcontroller development. Okay, so first some context. This is what the classic software development lifecycle looks like. You first enter a planning phase, go into some analysis, design, and then implementation of your system. You do then some testing and integration, and in the end, you go to the maintenance phase. This, of course, has its problems. So yeah, slow builds, you have to test manually, release events tend to be manually planned, and there's little of no monitoring, causing fear of updating and vague bug reports. So there's a lot of problems that arise from this classic way of software development. So a decade and a half ago, the tech companies came up with a more structured approach for doing software development. And they this was done by combining development and operations team, and to make sure that they work closely together. So this can be nicely represented in this kind of infinity loop that you see here, where you have all the different phases of the software development lifecycle. So first, you have a planning phase and a coding phase, building phase and testing. And then you go on to the operations part of the software development lifecycle. And the idea is to cycle through this loop in rapid iterations. So you get feedback as soon as possible and as fast as possible. So titles are a bit, I don't have my titles. So DevOps practices and methodologies. What's the real benefit of this? You can save time in development, you can increase release frequency, and also keeping software quality. So this is a classic mistake that people make, that you have to sacrifice quality for increasing the frequency. what research has shown is that if you focus on the frequency, the quality will also improve. Because yeah, if you have a bigger frequency, then you get more rapid feedback, and problems in a running system don't exacerbate that much. And then lastly, by collecting feedback and data through the entire chain and be alerted of issues, you can improve efficiency by focusing added value and automation. So there's a classic saying in software systems that if you implement a software system, it mimics the communication structure of the teams working on this software system. This is called Conways Law. And there, you can use this Conway's Law to do the inverse, where you have you make sure that the software system is has a sensible architecture, and then let your team's organization and communication structures follow this structure of your software system. So this is one of the ways where DevOps can be used for change management and to restructure an organization. The implication of this is that the architecture of your software system becomes really important, because minor discrepancy in this kind of software system can ripple down to the complete organization. And so, as a conclusion, strictness is very important if you create this kind of architecture of your software system where your company is evolved around it. So what is DevOps? So DevOps is a combination of a mindset, practices, and tools to bring software development and operations activities closer together. So the main objective is to reduce the time to market for software products, and also improving the delivered quality. And this is done based on the agile methodology, and then also automating as much as possible the builds and verification and test phases. So how is this done exactly? DevOps focuses on these 4 key metrics that are originally came from the lean manufacturing methodology developed at Toyota in the 90s. So the lead time for changes. These are 4 metrics that you can use to get an idea of how well your software development and deployment is running. So the first one, lead time for changes. That's basically the time it takes for a change on a developer's PC to run into production. This is something that can be measured, because you know, okay, this developer is working on change, and the time by the time it's running in production, that's the time that you have to measure. Next one is the deployment frequency. That's basically how often do you push a release to production. Third one, the time to restore service. In case there is a problem in production, how much time does it take to recover from this problem? And then the last one, the change failure rate, means how how many of the changes pushed to production cause in a malfunctioning of the system. So here are some examples that we've seen with Nalys from implementing a DevOps way of working. So by using Bazel build system, we saw that together with caching, the builds became 100 times faster. There's an increased development productivity up to 300% with CI/CD, and also the time to recover from some server apps that we have was up to 60 times shorter. So to recap, yeah, we've seen that this applying these principles really improves the the development lifecycle. So my colleague Vincent is now going to talk a bit about the software development lifecycle in embedded systems.
Yes, hello everyone. My name is Vincent van Gestel, and I have been a DevOps engineer for a bit over 3 years now. I've worked at several companies, and I've worked on several different types of DevOps implementations, mostly for companies doing embedded systems development. In this first part, I'm going to talk about how embedded development and how the software development lifecycle for embedded traditionally looks, some of the pain points and pitfalls that this introduces, and then we'll move on to how we can see how DevOps can be applied to figure out where the problems lie, to pinpoint them, and also offer some solutions. So let's kick things off. There are 3 ways to traditionally do development, or that are most common to do development, as development is not done at random. The first one is a waterfall approach. The second, V-cycle, and then last we also have the ever popular agile way of working. First off, waterfall, you probably know that this methodology isn't particularly popular anymore. It has been criticized quite a lot for being very inflexible, as this really designed to be executed in one big go, to have a final product all the way at the end, and not really to jump back when we need to shift the design or react on impulses from customers or the market. And V-cycle emphasizes testing a lot, which is great, and it will also link these tests back to the requirements. This is useful in fields like the automotive industry, where we have very strict requirements. But a problem that I have with this setup is that testing is again pushed to the end. It's the second leg of the V, and in DevOps, we'll see that more continuous way of testing is definitely preferred. Finally, we have agile, and I think this image really shows as well. The agile is basically waterfall again, but in a circle instead of a line. And the point is that we're going to keep this circle as short and tight as possible, so we can iterate over it many different times. A problem with this is that if you are keeping your sprints tight and short, if you're fixing resources and time, which is the case with agile development, elements of a lesser perceived value in the now might fall out of the boat. So agile tends to focus heavily on features and functionality. So elements like testing and documentation run at risk of being postponed to later sprints if there just wasn't enough time to get them done. So then you end up in a situation where you're developing the code now, but doing the testing much later, and that's a problem. DevOps is an evolution of agile, so it still holds some of the same philosophical aspects, but it's going to put a lot more things concretely and strictly. It will also put a bigger emphasis on the second part, the ops part, which is almost completely left out or very simplified in the original agile way of working. And this allows us, with a higher focus on CI/CD and automation, to get this way of continuous testing, continuous delivery that we want. Some common company structures that we also encounter contain the following things. We have siloed development teams. A siloed team is defined if the team is working on their own little island. For the most part, communication between the teams isn't that great, and they tend to end up being a bit isolated. How does this come? Well, this is a consequence of simply development on certain embedded subsystems can be fairly difficult. Not everyone knows how to write drivers or write some assembly code for the very nitty-gritty stuff. So expertise tends to be grouped together in these teams. And if communication isn't incentivized, then they can get isolated fairly easily. Another thing we see are dedicated testing and validation teams. Now, this isn't necessarily bad, but again, if you don't have good communication between your developers and your testers, then you run the risk of ending up with a test suite that kind of misses the point and doesn't really test what is supposed to be tested. This is usually caused by the difficulty of automating testing with embedded systems. Simply because you have this dependency on real physical hardware, and it's not always easy to get that right. So in some cases, a lot of testing is still done manually. And for big companies, it's even outsourced to other companies in India or China. Something that in DevOps way of working, this is something that you'll try to avoid by lowering the barrier of entry for developers to write and run their own tests. And then finally, hesitancy with change management. This can be any sort of change, both in process as well as on code. This is a consequence of the previous point where you don't necessarily have a way to validate your changes easily and quickly. Then you don't really know what the impact of these changes is going to be. So this results into some common pitfalls. If you have siloed teams, then they tend to develop or create their own little ecosystem, their own ways of working, their own environments. Your company might think that they're doing DevOps because we're doing containers or something. But if every team has their own set of containers and they're not comparable at all, then you'll still end up with difficulties for them to work together on features that touch multiple teams. If you have a dedicated testing team and validation, as a direct result, you'll immediately push testing to a later stage in the development, as developers won't be doing it. And then finally, with the change management, if you're afraid for accepting changes in your code base, then you're going to try to protect yourself with these very slow, strict and manual review processes, which will slow down development incredibly and also result into more context switching for the developer and more overhead. So let's see how we can use DevOps to fix some of these points. Again, here we have our little DevOps Infinity image. And the exercise that we're going to do now is something that I urge you to do at your company or at your client as well. So we're going to take the entire development lifecycle and zoom in on really one of these particular points and see what are the complaints that we hear at this point and how can we solve this, usually through some form of automation. So let's kick things off with code, because we can't do all of them, so that would take too much time. For code, how do the code bases look? They grow naturally over time, and they tend to end up a bit of a mess, varying wildly in style and structure all over the place. And this is emphasized even more if you're dealing with siloed development teams. When a developer is moving from one place to another, they'll have a high cost of context switching. A way to avoid this is by introducing a shared CI/CD process across the teams, across the entire code base, that enforces some rules like style and how directories should be structured. This might not be welcomed with open arms at first, because developers tend to not like changing how they write their code, but in the end, you will end up with a product that is uniform across the board, and everyone will feel that they're working on the same thing and working towards the same goals, which is really important. When you're writing these tools, you'll also have to take into account how the code is organized on a larger scale. If you're dealing with a monorepo or many different smaller repositories. With a monorepo, you'll need to introduce additional logic so that you can tear the repo apart again to focus on the parts that you're actually interested in for your smaller scale processes. The other way around, if you're dealing with many different repos, your processes need to scale, because it's one thing to manage a CI/CD pipeline for a single repository. It's another thing entirely to do it for hundreds or even thousands of repositories. Let's take a look at builds. This is something we've all encountered without a doubt. Long build times, build system sucks. It's horrible. Developers are losing their valuable time waiting on compilations. And if they really dislike using the build system, then they'll actively start to avoiding it by combining more changes into a single review. And studies have shown that this is really bad because larger reviews will allow more bugs to go through, not only because there are more lines of code that can contain bugs, but also because for a human reviewing all of these lines of code, it's just very difficult. And this is a direct result of people not wanting to build that much. A way that we can fix this is either by utilizing the build system in a different way, usually by introducing some sort of caching system that you're only rebuilding the parts that you have to. Another more drastic approach would be swapping out the build system entirely or a part of it. We have seen great success using Bazel in this regard. And if you're interested to learn more about that, stay tuned until the end of this presentation, as one of the next NTech presentation will actually be about applying Bazel. Let's look at the other side of the coin, the ops part, starting with releasing. Releasing is often a very difficult process involving a lot of people. At one of the companies I've worked at, there was even this thing known as a release day or multiple days if it didn't go through in one day, where they pick up several key people, put them in a room, and they're working on the release, don't bother them. This is, of course, a very inefficient way of working, and it will hurt your time to market incredibly. That's on the macro scale. On the micro scale, you can have the same thing. Developers committing their code to review. If that review takes a long time, then developer will also lose this time. He might have switched to another task and have to context switch back once the feedback comes in, or he's wasting some precious time writing multi-page papers on why his change should be accepted. To avoid this, we can invest more into automation. For the macro scale, an automated integration process where you have some sort of staging area where all of the latest stuff is gathered will make it possible that when the time comes for the release, it shouldn't be more difficult than just pressing a button. On the micro scale, we can look at automating certain aspects of the review so the human reviewers can focus on the real important stuff, the actual implementation, and the bots can do the static code analysis or the style checking and so on. Finally, I want to talk about monitoring. This is a very important aspect for DevOps way of working, that you base yourself and the optimizations that you want to do based on real actual data that you've gathered. And this data is often not present or very difficult to acquire. And then people will have to trust their gut, like, oh yeah, this process takes fairly long, maybe we can look there. It's a lot better if you can really pinpoint it and show it in graphs, like here are the clear, obvious bottlenecks. And then another benefit, once you have done the work, you can see again in the data how it has improved the workflow overall. This will increase the perceived value of your work throughout the entire company, so you can continue doing the good work instead of people not appreciating it that much. So who is going to do all of this work? A trend that we've seen in the industry lately are platform teams. It's a team of developers dedicated to developing and maintaining this platform, and it can be CI/CD pipelines or automation scripts and so on. And it's important that this platform is considered to be really an internal product of the company and gains continuous investment and maintenance. Because if it doesn't, then it will not grow along with the company, and it will not shift along with the new requirements that may arise. This also solves some problems with companies trying to adopt DevOps. This is information that comes from the State of DevOps report of 2020 done by Circle CI and Puppet, where the three main issues that they found when companies are trying to adopt DevOps are lack of time, lack of expertise, and lack of standardization. If you have a team dedicated to this work, that solves lack of time, so probably have time. Lack of expertise, they might need to build it up at first, but it will stay within the team instead of just a random developer setting up some sort of platform and then going on to other work. and the platform slowly dying as a result. And lack of standardization, if you have one team in contact with everyone else, then they can enforce some sort of standardization or come to some sort of compromise between the different teams. So you might be thinking, isn't this just another silo? And I would say, no, definitely not, because silos are defined by their lack of communication, their isolation, while a platform team and communication are essential. They have to be the bridge between all of the other teams and make sure that the platform that they provide and that the developers can then use is something that they want to use. Otherwise, you'll get nowhere. Two of the first things that they'll be doing are creating a shared CI/CD process that will harmonize the development. This is really important, as this CI process will likely be the foundation of every other improvement that you're going to do, be it automated testing, or automated releasing and integration, and so on. So it's very important that this part is considered vital and receives the proper maintenance and attention that it deserves. A second part, and this is more explicit for embedded development, is providing some sort of infrastructure to access real setups, or maybe emulated setups. Because primarily they're going to be used by the test setups, although it's interesting to expand upon this concept to allow developers access to these setups as well, especially now that we're all working from home. But why I say maybe emulated setups and the physical part is not that necessarily that important, it is if you can emulate or run tests in an x86 environment, you're going to reduce the need for actual devices for a lot of your testing. And this need for real physical devices tends to become a bottleneck quite quickly. So let's take a look at different stages of testing and how we can apply this. Our main goals are to shorten the feedback loop to developers so that they get valuable and quick feedback fast. And another element that we're trying to solve is run an appropriate amount and type of tests at the appropriate time, so we alleviate our need for real physical setups. This will increase efficiency over time by quite a lot. And this phenomenon is called shift left testing, where we try to catch as many bugs as possible as early as possible. So let's draw on this arrow a few different stages that we can identify. First, we have cheap static code analysis. With a little asterisk, this can also be fairly complex to do, but we're going to just take into account the cheap stuff. Then simple x86 testing. If that isn't enough, we can run in a virtualized environment on KMU, for example. Smoke tests on a real target, but the smoke tests imply that we're not really testing functionality per se, just does the thing boot, does everything start the way we expect it to. Finally, we can move on to some actual tests, full tests, and then finally, a bit jokingly, in the field testing, where we get feedback back from our users. Obviously, this is highly inefficient and comes at a high cost. Obviously, the more we move to the left, the more time and cost goes down. If we draw some boxes around them, we can see all the way to the left, we have cheap x86 land, and all the way on the right, costly physical. And in our first use case, we're going to see how this was applied at one of the companies that we work for. We have two use cases for you, as Toon mentioned. One is an embedded Linux device under test, where we have more options on how to do simulation, and it's easier to interface with the device because it has very common and practical to use interfaces like SSH. And the second use case that Toon will present is about microcontrollers, where you're a lot more dependent on the hardware itself, and that brings its own set of challenges for sure. So let's first do the embedded Linux one. And this is an example done at Soft at Home, where I am part of the SOFA team, or software factory. We are a platform team providing tools, CI/CD pipelines, integration automation, and so on. Soft at Home is a company that develops software for home gateways, set-top boxes, smart Wi-Fi, IoT, and so on. And their software runs on embedded Linux. And what we did to do testing and different stages of testing, how did we apply it? We tried to give a lot of focus to the developers in the feature teams so that they can do their development as efficiently as possible. And we try to do this by providing qualitative and meaningful feedback at these different stages. And the different stages that we can identify at Soft at Home are the following. First, we have local development, where the developer is working on his own workstation with potentially a target attached to it. Then when he pushes his code, it ends up in a repository known as a component. Different components are grouped together in a single meta component with some additional configuration. Different meta components are then again grouped together in a config, which describes the final image. And then when it's time to release, this config goes through a release process where it stabilizes and goes through a validation process. And if we slap some numbers on that to see how long each of these testing at each of these stages takes, we see a massive gap between repository and meta level, going from pipelines that last a few minutes to almost an hour. And if we draw our boxes again, it becomes immediately clear why this is the case. On the left, we can do most of our testing on containers in a cloud environment, while once we reach the meta level, we need to do a full build, we need to do testing on a real target, and it immediately becomes a lot more expensive to do. We try to keep time still down as much as possible by focusing on tests that are only relevant to the components grouped within the meta, but the pipeline will still take quite some time to finish. So if we apply the techniques of shift-left testing, we try to catch as many problems as early as possible, mainly in this left block. That way, the amount of times that we need to go to the later stages gets reduced as much as possible. And we don't end up having to go through an entire validation cycle over and over again, which simply would not be feasible to remain competitive. Some things that we did that was also interesting are reusing tests on these different stages. So a developer only needs to write a test once, and then it can be reused both locally as well as on target, thanks to the testing framework that we used and developed in-house as well. Yes, so that's what we want to do here. We want to catch mistakes early. That's the biggest takeaway. Now I'm going to give the word back to Toon.
Okay. Okay. So what I will highlight here is a system that we developed for a client, where it was a car sharing module based on a microcontroller. So an STM32F4 running a bare metal OS. So the idea, why did we need a test bench? What we wanted to do was to simulate and control the environment of the device. So we don't need to have a device installed in the field to run the tests. And with this test bench, it was possible to automate the testing, both hardware and software, inside a continuous integration process. All this to find, with the goal to find bugs as early as possible, to save time and money, to deliver better quality, and to avoid integration hell. This is an overview of the system that we created. So you see the Jenkins master there, connected to some build nodes where the firmware is built. And once this is built, the firmware is pushed to the Jenkins nodes running on Raspberry Pis, which then flashes the firmware on the device under test. Why did we use a Raspberry Pi? Raspberry Pi allowed us to interface with all of the hardware that the device under test provided. by making some custom hats that fit on the Raspberry Pi. The creation of these custom hats is quite easy, and you can find a lot of good examples on this online. So on this Raspberry Pi, for the car sharing module, we run a car simulator to simulate the complete environment of a car, and then also complete test framework. So to get an idea what it looked like, you see a few IKEA closets. We created some custom enclosure around it to wrap the cables neatly around them. And there you see we have on one plate, 2 Raspberry Pis connected to the device under test with specific hardware interfaces. This is a top-level view. Yeah, and this is an overview of the device under test that we had. So you see here, there's a lot of connectors for which we created a custom Pi hat to allow for testing each of these connectors and also flash the firmware on the device. So an overview of all the interfaces. Why do I show this? This is to give you an idea that even you might think while working on an embedded system that it's really hard to integrate this embedded system in some kind of CI, and that you need to physically be there with the device. Well, here you see it's not really possible. It's not really needed to have physical control over the device if you create all these interfaces for these hardware connections. So, for instance, we created an interface for the OBD plug of a car, Bluetooth, NFC connector, but also, yeah, most of you would be interested in the things like the UART. Those are things that you find on any kind of embedded device. So this is just to say that you can go a long way with a simple setup like a Raspberry Pi with some custom hats, and that allows you to integrate fully into the CI your embedded device. In terms of software stack, yeah, we used a build-root image with then support for all the hardware peripherals built on top of that, and we used PyTest as a testing framework. Earlier we used robot framework, but we found that PyTest allowed for more flexibility and is more future-proof. So to conclude, of course, we're a technology company. We created an offer for customers to, if you have any problems with implementing DevOps, we have quite some experience in all these tools. So we're really adaptive in this. We can build on, we can help you with one part of this cycle or implement a complete solution for you. We have a lot of expertise in-house on this. So just to show a bit the methodology that we used, we use Agile and Scrum methodology for 2 or 3 week sprints. And that's really crucial to work fast and efficient. We also focus on the CI/CD systems at the start of the project to immediately get the things right. And wherever we can, we use open source solutions because we think that's the way to go in the future, and to make sure that every tool we use has a strong community behind it. So for this, we created the website, and you can find it here. I will share the slides after the meeting. So yeah, if you're interested, have a look. There's some contact details there. So yeah. Yeah, this concludes the presentation. If there is any more questions, feel free to ask in the chat now so we can open a discussion. Let's see if we have any questions. Chats.
While people are typing out their questions, you can maybe also show the next presentations that are scheduled.
Yeah, sure. So these are in the NTech formats. We try to organize a presentation once every month. The next one is the 28th of April on Bazel build system. This is quite a good build system that we originally developed by Google, that we promoted inside one of our customers. So this is a place where we have a lot of expertise. So we really look forward to that presentation. On the 19th of May, we have one on data integrity and CSV, and then the 26th on the importance of cybersecurity. Okay, I see a question here from Thomas. Thomas says, I'm currently in a CI/CD role at my customer as well. However, I'm getting fed up with Jenkins, which feels a bit outdated. What is your preferred CI/CD tool for embedded environments? Personally, I tend to gravitate towards GitLab because they have a fully integrated approach, repository management, but also project management tools, and then also CI and CD. I don't know, Vincent, maybe you have some more elaborate opinion on this?
No, I also like working with GitLab CI. Of course, you have a requirement that the company is using GitLab, otherwise you won't be able to do it. GitHub also supports something very similar recently with GitHub Actions. But a problem that you have, of course, with GitLab, and something that Jenkins handles a slightly bit better, is accessing your nodes in a really straightforward way. That is integrated really well within Jenkins, even though it is indeed getting quite old. If you want to do something similar with really on-target testing using just GitLab, you will likely have to set up another system for scheduling and reserving the actual devices.
Add to that, inside Nalys, we often use drone CI for the internal projects, which is quite a recent CI, but it's neat to use and quite clean.
If someone wants to also just mention their question without having to type it out, it's also possible. That's why we're doing it by the Zoom way. I'm not sure if there's a way to raise hands or something so that we have some way to guide the conversation.
How come Bazel is that much faster than other build systems?
this is a good question about Bazel and why it is so incredibly fast. It relies heavily on caching. It caches a lot, and that way, when you need to rebuild something and it already has it somewhere, it will very quickly and easily reproduce it. That's, I think, the biggest takeaway of why Bazel is so efficient. If you want to learn more, of course, there is also the upcoming webinar specifically about Bazel, where they'll undoubtedly go into far much more depth. But crux is caching a lot. Anyone else?
So, okay, if there's no more questions, we'll end the session here. Of course, feel free to reach out to either one of us or the NTech email address. So yeah, thank you for joining the presentation today. We hope you learned something, and yeah, I look forward to seeing you somewhere.
Likewise. Right. Bye, everyone.
Bye bye.